This car is going to collide into this van of mass 1,800 kilograms. The van is stationary on a frictionless track. The two vehicles move off together as a unit after the collision. 4.1. State the principle of conservation of momentum in words. So what we know about momentum is that when it is in an isolated system, the total momentum will always remain the same. So the total momentum of this entire system will be the same before the collision, and it will be the same after the collision. And so if you wanted to give that a proper definition, it would say, in an isolated system, the total linear momentum before a collision is equal to the total linear momentum after the collision. Question 4.2 says, calculate the speed of the vehicles after the collision. So from what we were given, we know that this car over here was moving at a speed of 25 meters per second, and this one was not moving at all. And after they collided with each other, they moved off together. So what we do know is that the velocity of this, both the objects afterwards are going to be exactly the same, because we know that they moved off together. To work this out, we're going to use the conservation of linear momentum formula, which goes as follows. Momentum initial is equal to momentum final. Now we can expand that formula because we know that momentum is equal to the product of an object's mass and its velocity. So we use that formula for each object during each part of the collision. So first we have the system initially before the collision, and then we have the system after the collision. Okay, so now we can just fill in all of those values into our formula. The mass of the car is 1,200 kilograms. Its velocity, it was given to us as 25 meters per second. Then the van, its mass is 1,800 kilograms. Its speed is 0 because it was given to us that the van was stationary, and you know that when an object is stationary, its velocity is 0. Okay, then we put our equal sign. Now after the collision, we know that both of these objects stuck together, and so their velocity will be the same. So we can just leave that v as an unknown for this part of the question because that's what we're going to be figuring out. Now if you solve for that, you should get an answer of 30,000 on the left hand side and 3,000 V on the right hand side. Now it's just a matter of getting V alone by itself, which you should be able to get by dividing 30,000 by 3,000. So you do that and then you get an answer of 10 meters per second. Note that it's not really important to give us a direction here because they've only asked us for the speed, and speed is a scalar, so it does not have a direction. Question 4.3. Determine by means of a relevant calculation whether the collision was elastic or inelastic. Well, what we know about elastic collisions is that no kinetic energy will be lost during the collision. So what this means is that the kinetic energy will be reserved. The total kinetic energy before the collision must be equal to the total kinetic energy after the collision. But we are not sure if this is what happened here, so we have to go and calculate and figure that out. The formula for kinetic energy is 1/2 mv squared. Okay, so we know that the mass of the car is 1,200 kilograms. Its speed was 25. Then we're going to add also the kinetic energy of the van, which was 1/2 times its mass, 1,800 kilograms, multiplied by its velocity, which was 0, squared. And so what you'll realize is that this whole part over here is just going to fall away because if you multiply something with 0, it always just becomes 0. Now, if you calculate that whole thing, you should get a big answer of 375,000. Now, what we're going to do next is calculate the kinetic energy of the system after its collision. So, kinetic energy final, and we're going to use the same formula, which is a half mv squared. So we put a half times the mass of the car, which is 1,200 kilograms. Its velocity we calculated in 4.2. Its final velocity was 10 meters per second. So 10 meters squared plus the van, that's a half times its mass, 1,800 kilograms, multiplied by its velocity, which is also 10 meters per second because we know that they stuck together after the collision and they moved off together. Okay, so if you type all of that into your calculator, you should get an answer of 150,000. Now what we have to do is compare these two answers. What we can immediately see is that this value over here is a lot lower than this value over here. So what happened to this value? We know that kinetic energy can be lost during a collision. So we can see that this is definitely what happened here, because we started with 375,000 joules and we ended off with 150,000 joules, which means that somewhere during the collision energy was lost, and that's why the system now has less kinetic energy, which means that this is not an elastic collision. This has to be an inelastic collision. Okay. Moving on, after the collision, the combination of the vehicles move into a real road and stop, covering a distance of 20 meters. Calculate the magnitude of the frictional force. Okay, since they're talking about force, we know we're going to use our Newton's second law. The formula goes F net is equal to mass times acceleration. But there is a problem with this because we can't immediately use this formula just as it is because we have two unknowns. We do not know what the net force is, and we know what the mass is, but we don't know what acceleration is either, so we have two unknowns. So it's not really going to work out if we use this formula just as it is. What we can do is use a formula of motion. We can use this formula that says final velocity squared is equal to initial velocity squared plus 2 times acceleration multiplied by displacement. We can fill in all of these values. We know that the final velocity is 0. How do we know that? We know they told us that these cars, they come to a stop. So when they come to a stop, we know that the velocity has to be 0. The initial velocity will be the velocity we calculated in 4.2, which was 10 meters per second. I know that was the final velocity for that question, but what we're looking at now is what happened after the collision. So it's in a separate section from what we calculated before. So that's why the 10 meters per second now becomes our initial velocity, because what we're only looking at right now is what happened after the collision. I hope that makes sense. So the initial velocity is 10 squared plus 2 times acceleration, which we don't know, but we know the displacement they gave us is 20 meters. And then we have A. We can neaten this up by taking the 10 squared to the other side, and we know that 10 squared is 100. So on the other side we'll have minus 100. On the side we'll have 2 times 20, which is 40A. Now we can get A alone by dividing both sides by 40. So minus 100 divided by 40 is equal to A. Now if you solve that further, you should get a final answer of acceleration is equal to minus 2.5 meters per second squared. Now what we can do finally is plug this into the F-net formula. But what we also have to realize is that the only force acting on these objects is friction. That is the only force, that there's no applied force, there's no tension, there's nothing. There's the only force that could cause these vehicles to stop is friction. So this entire F-net we know is just going to be equal to friction. So friction is equal to mass times acceleration. The mass of the objects, if we calculate them together, it's 1,200 plus 1,800, which gives us 3,000. The acceleration we have as minus 2.5. And if you solve that, you should get an answer of minus 7,500 newtons. You don't have to worry about the negative, because usually the negative tells us the direction which the force is moving in. The direction in which the force is. But they only asked us for magnitude, which means we don't have to worry about the direction. So what we can say is that friction is equal to 7,500 newtons. And that is your final answer for that question.